going on, ladies and gentlemen? We are working on a Trane. This is an 18i two-stage system. It's got the EEV in it, and I'm just here kind of double checking. We had a tech come out. This thing was shutting down on pressure lockouts and would run fine in first stage, and then when you put it in second stage, at least when he was running it in second stage, it would for some reason start to bog out and the pressures would start to just nosedive and go out on low pressure. So I'd seen this a couple of times. Okay, been sitting here waiting on a call, so now we're in second stage. In case you didn't know, this green light here, it's going to flash 2 times for second stage, 1 time for first stage. So we're in second stage now, and you also see it flutter as that EEV in heat mode adjusts. We're running air conditioning, which means that EEV that's in this unit should be stepped wide open for full flow, and then the indoor EEV in the air handler is going to regulate the refrigerant flow and cooling. But the EEV board, I've seen this in heat mode on these units twice. So first time somebody condemned a compressor that was bad in second stage, and then came out, put a compressor in it, didn't fix the problem. It turned out that when the EEV board was getting a call for second stage, it was just throwing the EEV out of whack and shutting it down, and then the compressor was going out. Put an EEV board and it fixed it, and that may be the same problem here, with the exception of the EEV board inside is probably the problem. I'm just here to double check it. The guy said we turned all the power off, reset everything, and it's been working fine for the last 4 days. This is July 24th. But I'm double checking it because the EEV board for the air handler is not available right now. They have them, but they're on back order. I guess these control boards are still catching up from the chip problem we had during the pandemic. Some of these boards are hit and miss. Some we can get, some it's taken a while to get them. And I did bring one out of we've got a training unit set up, 2 training units set up at a shop. One's an XV, one is a 2-stage 18i with a TAM 8 air handler on it, which is I believe what's on this. I did bring that board out of that unit with me just in case, as a temporary kind of band-aid until we can get the new one in. Still under warranty. It's 2015 under parts warranty. But as you can see, we're in second stage and the pressures are running fine. It's about 78 degrees out here. We're getting a break today from the heat we've had, and that subcooling will gradually go up. The subcooling on this unit is 9 degrees, and it's gradually creeping up as that airflow, as that blower ramps up in there from first to second stage. 17 degree superheat. But I'm going to go under the house real quick. We're going to check the stepper motor on this thing, ohm out the sensors, and peek around a little bit. So now we're under the house, and I've got the outdoor disconnect turned off. I'm letting this blower run. I want the temperatures on this coil to stabilize out with the airflow so I can test my temperature sensors, and then we'll go home out and check that stepper motor in here. And as long as those things check out okay, I'm comfortable with the diagnosis of the EEV board. It's just that the thing's been running fine now for 4 or 5 days, and it's 2 years from being out of warranty. So if there is a problem with the board, we want to get the guy the board while it's still under, at least under the part warranty anyway. You'll have to pay for the warranty repair, but that'll save him the part. But hey guys, these lights I got at Harbor Freight, man, like that little thing right there, and they hold charge for a long time. They're small, compact, very strong magnet on it, and you could just find any piece of metal somewhere, stick it up there and turn it on. Works great. But anyway, we're going to double check some things on it, and it's just the EEV board. He's a little frustrated. We're not able to get one. They didn't have one anywhere in the state. It's going to be on back order for this particular unit, and it's coming. Now this is a TAM. This is a TAM 7, and we got an 850 thermostat inside, and we've got a relay panel mounted right up here. So the thermostat communicates with that relay panel, and then that relay panel turns on the unit. 24 volts on this side, communicating on the thermostat side. So let's open this thing up. Should be balanced, and that's why I say I'll turn the outdoor unit off. I'm going to let the air blow through this thing, and both my sensors should stable out to about the same temperature at that point after a few minutes. It's been about 10, 15, going on 15 by the time I get this door off. But I'll do this, and I test them by using the DC voltage. Hopefully we're not getting any air noise here. So I'm going to probably go ahead and shut her down. Where the fuck? Where's the disconnect? Oh, back here behind me. Alrighty. Got breakers up here. So I'm going to turn that off for the time being. And that's what we're looking at. And we're going to slide this board out of here and try not to make a mess of my thermostat wiring over there. And then we're going to go over here to these test pins, and I'm going to put the power back on so I can get my DC voltage, but I'm going to get my little needle probe leads going. So we're going to check DC voltage on these terminals, and they should both be reading about the same by now. And that's why I do it. I just do it by the DC voltage. I mean, you can own these out. There's a chart shows you how to own these sensors, these coil sensors out. I can get my leads plugged in. But the sensors I'm talking about are your coil sensor, which is here. It's your ET sensor, and then your GT sensor, which is up here on the suction line. And I usually just go by DC voltage. I said you can ohm them out, but DC voltage should be pretty much about the same if they're both good. If you get one that gives you like a 1.6 and another one that says 2.3 or 0.9, or way out of whack, then you know you got a bad sensor. Then you can confirm it by doing your ohms. So I am going to set this for DC voltage, and we'll do the black one first, which is going to be our gas sensor. And we got 1.6, which is right where it should be. About 72, 3 degrees in the house, roughly. I wish these needle probes were a little more rigid. You try to get them pushed down in there, and they want to kind of bend on you. And I got 1.6 right there. So both of these sensors are reading 1.6. 1.6 is typically going to be in that 70-ish to 4 degree range, 69, somewhere in there. I know it's right. I've seen it 1,000 times of testing these things. So those sensors are reading the right temperature. So they are not causing an issue with measuring an inaccurate superheat across this coil and telling this board to do some crazy stuff with the EEV adjustments. So now we're going to ohm out the stepper motor itself, which means I have to come over here and unplug it. And I got these water pipes back here behind my head, if you can't see. And it just happens to be that the one sitting at the back of my neck is the damn hot water. So anyway, so with these, you got your plugs here. And you got your stepper motor. And you're just going to go in here and ohm these out. And I've got to remember the combination on this. Alright, so these are your two different types of stepper motors. I can't remember the names of them from the class. Well, this one's like a Fujikaki and something, so I can't remember. But they're Asian type, Chinese, Japanese names, I don't know. But anyway, there's two different versions of this. You've got your bottom clip stepper motor that, and like this is the one that's on the outdoor unit, and it clips to the line that the EEV is mounted to, and that's what holds it in place. Air handlers have these. You've got a metal top strap, and then the end of this EEV has little divots in it, and then you've got impressions on each side of this metal clip, and then once you get it on, you just turn it until it snaps into place. This is the ohm chart, ohming these things out, and this is the one I've got. So basically both of these are going to ohm to 46 ohms. When you're testing them, you just got to make sure you're using the right chart and identify the right stepper motor that you have in place. We are using this one. So basically what happens here is I'm going to ohm gray to all the other four wires, and I'm going to be ohming the windings in that stepper motor. And who's that? Craig Migliaccio. He's got a video where he actually cut one of these things open and showed the magnets and showed how that thing works. And he had a little board with DC voltage set to it, and as he was touching each one, you could see that thing twisting and turning and adjusting that screw valve inside that EEV. So you might want to go look at his video on that. It's pretty cool, actually. It kind of gives you a better idea how these things operate. It's the same thing. His was for a mini split, but it's the exact same process. Works the same way. So we're going to do gray to all the other colors, and see what we come up with. So I'm going to set myself to ohms. In this situation, I'm going to turn it off. Because the thermostat had reset, and the blower was starting to come on, and the annoying air noise. So I'm going to stick one of my leads in here on the gray wire. These holes are kind of tiny. Trying to get the wire to go up in there. So there we go. And then you're simply just going to ohm it out against all of these other four wires. So we're going to do that one. So I got 45.62 there out of 46. We're good. 45.6 on that one. 45.7 on that one. And 45.7 between those two. So stepper motor is ohming correctly. Our sensors are reading correctly. So I'm pretty confident with the diagnosis on the EEV board being a possible issue with this. I mean, it's been running fine, and that's the thing about these TAM units and the 7/8s, the 9s, the XVs, some of this stuff. Some of this stuff you just go out and you turn the things off, just break the power to them and turn them back on, and they run just fine. And it's just like, what in the hell happened? So especially the XV system, jeez. Anyway, so we'll get all this put back together. We're going to get it turned back on, and he's just going to have to wait on that board, unfortunately. I'm putting the one back in the training unit. I'm not going to leave it here. If it wasn't working, then I would probably do that, but I need to put that back in the training unit for training purposes. If we can't get one for his house, we're not going to get one for our unit. So I'm going to go ahead and let it ride. If it quits working, we'll bring it out here. It may not quit again. It may just have been a fluke. We're just going to replace that board just to be on the safe side. These are some fickled pieces of equipment, so we'll get it put back together and get it turned back on. Alright, we're back outside waiting for that thermostat to reboot and come out of delay. So I said, this 18i, you got a defrost board in it here, typical Trane defrost board. The newer ones, they don't use that board anymore. The newer ones look similar to this, as far as at least the way it looks anyway. Contactor, you got your DC, you got your rectifier there for your second stage. Obviously your capacitor, the EEV board for the outdoor unit. I'm not going to take the side panel off, but there is a stepper motor and an EEV in there. There's a suction pressure transducer in there, and then a suction line, temperature sensor on the true suction line. So when you run this in heat mode, this valve obviously is your outdoor EEV, TXV, whatever you want to call it. That's your refrigerant flow gets regulated out here in heat mode. And then that transducer that's reading your suction pressure, translating it into a temperature, same way you do on your gauges. Then you got your true suction line temperature reading the suction line, so it's maintaining superheat on this outdoor unit when it runs in heat mode. And your suction pressure transducer is plugged here. Your outdoor ambient temperature sensor goes to your defrost board. Your coil sensor goes to your defrost board. You also have your temperature sensor here that I was telling you about. Let's pull the side panel off real quick. So there's your suction line temperature sensor there. Comes back up through here, plugs to this board. So it's reading the suction line temperature, and then it's reading your suction pressure, correlating that to a temperature, reading superheat from those 2 points, regulating your stepper motor. Here's that other stepper motor that clips on the bottom, and then regulating your refrigerant flow in heat mode. But she's back on and running. And turn all this back on real quick, which, I mean, I've already checked the pressure, so I'm just going to turn all this back on so I can get my final numbers. But yeah, this thing seems to be running fine, but we're going to go ahead and get that EEV board. Like I said, the one I've got with me, I'm going to take it back to the shop, put it back in our training unit, because we use that when we bring the new guys in to go through and do all the training. Anyway, it seems to be running fine, and it may never have a problem again, but for whatever reason, when it was going into second stage, which I'm going to jump it out real quick, put it back in second stage just out of curiosity, and this will energize back to the indoor unit, and it'll ramp that motor up. Heard that compressor sound. Went up into second stage. Our light's now flashing twice for second stage. We'll let it run a little bit, let these pressures stabilize out, but you may never have a problem again. These things are finicky, and you go out to them and they're showing this, that, and the other, and then you just turn off all the power and turn it back on, and it runs like a dream. But the only thing I can do is rule out the things I can rule out, which are the sensors and the stepper motor in there. We've never had a problem with the EEV, actual EEV on one of these things, which is this. Never had a problem with one of those getting plugged up or a leak once in a while at one of the braze joints, but we've never had a problem with that. It's either this or one of those two sensors. They're both checking good. So the one thing they all three have in common is being connected to the EEV board under the house in the air handler, and it may have a problem, so we're going to replace it. Anyway, guys, if nothing else, maybe you got a little training out of this on these Trane units. Picked up one or two things, I don't know, but I just thought I'd take it down. The sun's coming out, it's getting warm. Guys, stay safe out there. Like, subscribe, and appreciate you watching, and we'll see you on the other side.